We're given the following circuit with a current dependent source given as GVX. So here we have resistors R1 and R2 connected in series in this configuration, as well as R3 here in parallel with this dependent current source, and R4. We're going to formulate mesh current equations for this circuit, and then we're going to use the mesh equations to find VO, which is the voltage across R4, and Rn, which is shown right here, our input resistance, looking right through this circuit at the terminals here and here. Now we note that this current dependent source is a function of Vx, where Vx is the voltage across R2. So once again, we're going to use the mesh equations to find VO and Rn. This is when R1, for values of R1 equal to 50 ohms, R2 is equal to 1 kilo ohm, R3 is equal to 100 ohms, R4 is equal to 5 kilo ohm, and that G, our gain here, associated with the current dependent source, or we can say that this is a voltage controlled current source, is equal to 100 millisiemens. Now the first thing we do here is that we see R3 is in parallel with GVX, and we're going to do a source transformation so we can do mesh current analysis. So we take this parallel combination of a current source, but it's voltage controlled, in parallel with R3, and convert it into a voltage source, which is just simply GVX times R3, and then this voltage source is in series with R3. Now we can do a mesh analysis for loop A, and we can see that the currents in common is R1, R2, and R3. So this is just simply R1 plus R2 plus R3 times IA. And then what's opposite to IA is a minus R3 IB, and then our voltage source on the other side is just VS, and we see that this dependent voltage source now is opposite in polarity when we go around the loop here to minus G R3 Vx. But we can substitute. We note that Vx is just R2 times IA, since R2 is in part of this loop of IA. Substituting Vx into this equation, we have R1 plus R2 plus R3, and then substituting R2 IA in this equation, and we put it in the other side, that's just plus G R2 R3 VIA minus R3 IB is equal to VS. So that's for mesh A. For mesh B, we see that IB goes through R3 and R4. So IB goes to R3 plus R4, and then what's going opposite of IB is in R3 is minus IA. So minus R3 IA, and that's equal to G R3 Vx. Substituting Vx again for R2 IA yields minus R3 plus G R2 R3 times IA plus R3 plus R4 times IB equals 0. So that's for mesh B. So now that we have the mesh equations, let me highlight that here for mesh A and here for mesh B. Now we note that VO is equal to R4, voltage across R4, times IB, and that Rn is given by Vs divided by IA. Now when we substitute the values here for R1, R2, R3, R4, and G, we have the following mesh equations. For mesh A, we have 1.15 times 10 to the fourth IA minus 10 squared IB equal to Vs, and minus 1.01 times 10 to the fourth IA minus 5.1 times 10 to the 3 IB equals 0. So this is for mesh A, the top one, and then right below it is for mesh B. Now we can take this set of equations and solve for IA using Cramer's rule, which is equal to the determinant of A over the determinant of the system equations is equal to, in the numerator, V determinant of Vs0 minus 10 squared 5.1 times 10 to the third. And then in the denominator, we just simply have this set of equations, so we just put the coefficients here. 1.15 times 10 to the fourth minus 10 squared minus 1.01 times 10 to the fourth, 5.1 times 10 to the cube, and that implies that IA is equal to 0.9131, and then we multiply this by Vs, forgot to put that there, times 10 to the minus 4th Vs. IB follows a similar calculation where we have the numerator equal to 1.1, the determinant of this expression or matrix, Vs minus 1.01 times 10 to the fourth 0 all over that is equal to be the same determinant. In this case, this would be 5.5885 times 10 to the 7th, and this yields 1.808 times 10 to the minus 4th Vs. Now to find VO, we just substitute it here in this expression, so VO implies that it's equal to R4 IB, once again, which is equal to 0.904 Vs, since all we do is substitute this value into this expression and multiply it by R4. Then Rn is just Vs divided by Ia. We substitute Ia for this expression, and that yields 10.95 kiloohms. So our answer is this and this, where we found that Ia is evaluated as follows and Ib is evaluated as this expression shown here. So this example concludes the mesh current analysis with dependent sources.